Today's session is called Deep Dive, Continuous Delivery for AI Applications with ECS. Our presenter today is Asif Khan, and we're joined by a great team of moderators who will be able to help us out and answer any questions you have. So during the presentation at any time, you will see a Q&A pod. On your screen, you'll be able to submit any questions you have there at any time. If you have any issues, please do feel free to reach out as well. We're here for audio and technical issues as well. Our moderators' names today are David, Frank, and Pratap, and they're ready to flex their fingers and do a bunch of answering questions here.
Yeah, so Quentin, I'm on. Can you hear me? Okay, thank you, Quentin. And so let's get started. Hey guys, my name is Asif Khan. I'm a solutions architect with Amazon Web Services, specializing on containers, DevOps, and AI. So with that, let's begin. So when we talk about artificial intelligence and DevOps and containers, we are in this world today where, for example, the DevOps team has mastered their art, and they basically know how to deploy applications, and they know how to take an efficient pipeline and get code from development to production very quickly. On the machine learning side, we have a great team of data engineers and data scientists who build the models, get the data, train the data, and then build these models. On the business side, we have the application developers and the front-end team who are trying to deliver the most beautiful experience to our customers. And how do we marry the three of this? This is how we call it a circle of machine learning as of today. So we have the machine learning experts who believe or who deep learning is great, and we all want to adopt it. On the DevOps side, we have the challenge, or the missing link is, how do we operationalize it? How do we scale this? How do we make this continuous so the model, when the data feeds back into the model and I have a better model and a better inference that I can run, how can I deploy to this? This is what we are going to really touch upon in the next 45 minutes and then take questions down the line. What do we expect from this sessions? We'll briefly touch upon what is deep learning, why it is so relevant today for us, and where do we see it. We'll do a quick demo of how to build a deep learning model on a Jupyter notebook using Amazon Army, which has deep learning modules in it. We'll further deep dive into the DevOps part of this. What is the DevOps paradigm, and what do we need to take care of, think about in the DevOps tool chain for the AI model. And finally, we'll end the webinar with a demo of the CI/CD tool chain to deploy these models onto production and have a running API which uses the AI capabilities. So let's move on and get started. Deep learning is a branch of artificial intelligence, as we all know. Now, this is not new. We've been trying to do this for a long time, but what has happened in the past 10 years, due to the advent in infrastructure and due to the advent in algorithms, this has accelerated pretty fast. There are 4 major pillars of deep learning, which as we stand today, first is image understanding, the second one is speech recognition, then we have natural language processing, and finally autonomy, as we know about self-driving cars. Now, where do we see deep learning today, and where would we see it in the future? Deep learning is embedded into how we live today, how we are going into the future. So for example, if you use an Amazon product, there is the fulfillment centers are using deep learning to fulfill your orders. Amazon Alexa or Echo, Alexa being the voice agent, uses deep learning for natural language processing. Similarly, there are other examples. My favorite example is Amazon Go, which basically is a grocery chain which is in beta, but it uses deep learning and image recognition and things like that to get you that experience. And you will see this advent getting more and more. how does Amazon think about these AI services? And there's a bunch of these artifacts, and how do we layer this together to get our heads around it? The first or the most granular aspect of this is, where do I run my deep learning algorithms? I have a data scientist, so Amazon provides you the infrastructures in terms of GPU instances, Lambda, enhanced networking, and things like that. Going further up the stack, we want to talk about what are the frameworks that Amazon enables. So we love all the frameworks out there with an obvious bias to MXNet. And we also shipped an AWS Deep Learning Army, which is both available on Ubuntu and Amazon Linux, and I'll show you a demo of that. Further up, and this framework layer is really for audiences who want to do the algorithms, create the models, and go deep on deep learning and build their own custom models. But at a higher level of this, we have the AI platforms like Amazon EMR, Amazon Machine Learning, Spark, and Spark ML, which gives you that capability to run machine learning at scale and run traditional machine learning also. At the highest level of abstraction, we have managed services like Amazon Recognition, Amazon Poly, and Amazon Lex. Recognition is a managed service where you can actually figure out the features and the emotions of an image. And similarly, Poly has text-to-speech, and Lex does voice-to-text chatbots. And these are AI services that can be embedded back into your applications without doing the custom modeling and things like that, and advanced deep learning. But if you have the appetite, or if you're in the business of building those models and building deep learning inferences, then probably you want to play at the AI framework layer. So we have a toolbox in the AI services layer, which probably gets you from 0 to 100, and you choose the tool that you want to use for your use case. With that being said, let's move on to a demo. So we published an blog earlier in January about how to run deep learning models on ECS, Amazon ECS, and I'll touch upon this in the next demo that we come across. But the key takeaway is that we have training data, we do the training, and outcomes are model. And this is really the crux of the first demo, and we will do this on a Jupyter notebook. So what I've done before the demo is I've set up Amazon instance, which has the AWS Deep Learning Army, and I've launched my Jupyter notebook. Now on my Jupyter notebook, I can have custom notebooks or notebooks I create and execute them in a managed environment. So let's open the the Pi notebook. What this does is handwritten digit recognition. In this demo, what we are really doing is we are building the model and trying to use the model to predict what am I writing for my handwritten digit. We'll first fetch the data, the MNS data set, and then run the MXNet algorithms to train the model and then predict. And with Jupyter Notebook, you can take the cells, and in this example, I'm downloading the data, then I'm reading the data from the MNS side. So let's go and execute this. Executing is as easy as clicking this cell. So I got the data, I read the data. The next thing is I want to plot across these images. So I go and try to train this, and my code has read the different labels, and the labels are 50419211341. The next step is really to write an iterator, because I want to do it in a batch process and go so on and so forth. And finally, I will try to build a perceptron, which is basically a different layered way of doing a model. And I go and create the model and the perceptron. And once my perceptron is created, I can do my training. And as you can see, my training is going on the instance, and the accuracy is visible. And finally, I can take an image, and the training ended with a validation accuracy of 96.85%. Now, let's run this against an image that we have and see how it performs. So it knows that this is the number 7 with a probability of 3 nines. So having said that, this is how data science is moving forward with AWS Deep Learning Army enabling you with the libraries like Torch, Caffe, MXNet, and then also enabling a Jupyter Notebook that you can go and get your data and use the algorithms to train your models. With that being said, let's move back to the deck, the slide presentation. Fair enough. Now, we learned how to do the deep learning modeling and take the data and create the best neural network out of it so we can predict things and items. But what about how do we deploy this? How do we make this repeatable, like the inference part of it, and how do we do that at scale? And this is where the DevOps culture comes in. From a DevOps perspective, the key takeaway is we want to put the best practices, tools, and culture to make this as efficient and as repeatable a process as we can. To offset, DevOps is a culture. Now, devs and ops used to live in two different silos, and there was like hard walls between them. I've lived in that world, but today the dev and ops have come together, and today we don't have any more silos. We have a common team structure, we have common ownership, and we are able to talk to each other, collaborate each other, and fix problems and serve our customers faster and better. DevOps with microservices has become even more interesting. With the monoliths that existed, we tried to put the dev and ops together, and we have basically created that artifact of how do we take the code and deploy to production. Now with the microservices world, where microservices are decoupled services, they do one task and one task really well, and they have to be fault tolerant and deployed across the geography to make sure we are ready and available. The microservices are ready and available. Now, DevOps really accelerate this process. DevOps, if we have set up our DevOps tool chain, we can code the microservices in their own self-contained manner and use the tool chain to deploy it to the production environment and make it fault tolerant and so on and so forth. Going one level deeper into what are the pieces of DevOps that we talk about? There are two major components. One is continuous integration, and the second is continuous delivery and deployment. From a continuous integration perspective, I've written code, and my code should build and work in tandem with the rest of my package or components or my software stack. And that's where continuous integration comes in, where I run unit tests, I make sure my regression tests, and they are working well. From a continuous delivery perspective, we need to be able to deliver code at a continuous fashion and go through from source code where I commit changes to build where on test, and then staging and production, and make sure this cycle and feedback is continuous. And I get feedback back into the source code as quickly as we can and fix the bug and release this for. Gone are the days of fixing like 5 bugs or changing 200 lines of code with one commit. We actually are seeing more and more, or which has become the norm, is smaller commits, faster deployment times, and things like that. At the same time, when I'm doing continuous delivery, continuous deployment also gets very important because I need to test my deployment at every stage and make sure my deployment is running. My artifact is running, my code did not break anything, my stack is up, and things like that. So I commit my code, I run my code on my development environment, which could be a container, Dockerized based or otherwise. Then I push it to a build server. The build server runs it and gives me a thumbs up and says, okay, deploys it to a staging environment. The tests are run and staging environment, deployment is also okay. And finally, we move it to production and we see how we go. And we have multiple ways and also in production that customers are using in terms of blue-green and rolling deploys, and also some of the customers are using Canary or thinking of using Canary deployments to make sure that this is a robust process. But the key message that the DevOps lifecycle gives us is that we can take feedback from customers much more rapidly and iterate on it very quickly. And then with smaller commits and we can move it through the pipeline and get those results back to our back to our customers and make them happy. With AWS, you can use CloudFormation to do infrastructure as code or manage your infrastructure as code. So you don't have to go in and wire your physical racks. You don't have to get into your systems or VMs and configure them. But with CloudFormation, you can basically, in this example, give it parameters like key pair name that you want to launch the instance with, and you can pick up the instance type and so on and so forth. So that we all use, and from a CloudFormation, from an infrastructure as code perspective, I can provision an infrastructure from a CloudFormation and very quickly. The second big piece of DevOps is monitoring and logging. And it's very important once you've provisioned my infrastructure, once my code is deployed, to analyze the metrics and logs and finally understand the real-time performance of my infrastructure, how my code did on my development environment and how my code does in the production environment, and learn from them. We also have examples or use cases where the customers are moving towards an exception-based monitoring, that they've put enough monitoring in place, enough logs in place to make sure that things are on order, and when exceptions happen, they get alerted and they take remedial actions. What that does to the DevOps folks is that brings the DevOps culture back to the higher value and contributing to the business in terms of getting through release cycles fast and contributing back to the value chain. Some of the benefits I talked about in DevOps is ownership, speed of deployment, and going through the lifecycle fast and monitoring it and continuously making sure we understand what it is and deploying the best code possible. Another aspect of this in the continuous deployment and delivery lifecycle is I commit code as a developer. Once I've committed code, it goes through the unit testing and the build server builds it. At that stage, it's really important for us to do code reviews and static analysis to make sure the code I've written matches the highest bar that is being set by the team. And typically this is done by a lead architect, and this is where the small commits rolls back pretty well, because if I'm an architect, I probably could read 5 lines of code or 15 lines of code quickly and detect the anomalies, versus I'm trying to read 200 lines of code. So those are benefits that you get out of the box with the DevOps culture. So we've covered why DevOps is important, where DevOps brings us from a long-term perspective, and how does it enable agility in the development life cycle and makes the developer productivity higher. Some of these services that AWS has enable you to do this on the DevOps side, and also on the containers and the ECR side, container side, to make sure that the DevOps cycle is going as fast as we can. AWS Code Build is a fully managed build service that compiles the source code, it runs the tests, and it basically creates the binaries and deploys them. When you choose an instance on the AWS Code Build, you pick the instance type, you tell us the vCPUs, you tell us the image, and we provision the infrastructure for you. And then when you submit a job to us, you submit a job through a build spec YAML, and I'll show that to you in the demo. When you take the build spec YAML, there are 3 steps, 3 major components. One is the pre-build phase, then is the build phase, and the post-build phase. In the pre-build phase, you can actually call out to a scanning tool, for example, and check your code for security. And then you build it. In this case, we can build a custom builds using the Docker images. And finally, in the post-build stage, I can tag the Docker image and push it to ECR and things like that. You pay only by the minute for the compute resources you have used. And finally, it is tightly integrated with Code Pipeline and Jenkins integration. Code Pipeline is a workflow tool for continuous delivery and to set it up fast and things like that. So when a dev workflow is configured well, you have an alpha stage, you have a beta stage, you have a production stage, And you want the workflow to be controlled so that by mistake somebody doesn't deploy untested code or unverified code in production. And this is where code pipeline really helps to maintain that or manage that dev workflow. You can visualize your software release process, and you can actually pull code from code commit, build it on build, code build, and then deploy using the code deploy or third-party tools with AWS. We talked about CloudFormation at a high level when we talked about infrastructure as code, but CloudFormation what it gives you is an easy way to create manage related AWS resources, the infrastructure resources. It's more predictable, it's more repeatable, and your SysOps could go and deliver more value on the DevOps lifecycle. Now, the templates captures the relationships, and you can also easily view the AWS resources and the diagrams in templates and the diagrams and move it in that direction. So we've talked about the supporting artifacts of DevOps from the code pipeline being the dev workflow tool, the code build being the build tool, and CloudFormation provisioning the infrastructure. Now, once I have set this up correctly, I need to deploy somewhere. And in this case, what we're going to deploy this to is Amazon ECS. Amazon ECS or EC2 container service is a managed scalable container orchestration platform. So running one Docker container is easy, but running thousands of them is hard. And now you get into cluster management. So EC2 container service gives you that container orchestration to make sure that you can deploy hundreds and hundreds of Docker containers and manage them at scale. You do not need to install or operate any of the cluster management infrastructure, and that is taken care by the service, and it's a managed service, so that gives you out of the box. And thirdly, you pay again for the underlying resources you're using, the EC2 resources you're using, and you don't pay for the service. When we build the artifact or the code, when it goes to the build pipeline, there's a binary which comes out, and we typically are used to deploying binaries into our web servers or our production environments and into the runtimes. With Docker or with containers, Docker also kind of evangelized the Docker container registry that makes it easy to create an image, which is basically a binary with the runtime and the application code tied in together. And with this image, I can deploy this to any instance which supports Docker. With EC2 container service, EC2 container registry, we have enabled a private repository for these images. So you don't have to operate your own repository. You don't have to put your images on public internet. You can use Amazon ECR to store your images and manage them using the same security constructs like IAM roles, and you can do fine-grained permissions, and it integrates very tightly to the Amazon ECS service. So we talked about all the moving parts and the building blocks to come to this stage. And right at the beginning of the conversation, we started talking about how do we bring DevOps into a continuous delivery model that my data scientist is training the model. He really knows how to do it, and he should probably do it independently. And my DevOps people have really mastered the art of taking code and moving it to production. And my SysOps has been using CloudFormation to deploy infrastructure as code. Now, how does all of this come together? These are three different moving blocks. The way we think about this, and we publish this also, is when a data scientist trains the model with the data, he stores the model output onto Amazon S3. And we use Amazon S3 as a communication model between the data scientist, between the data science and the application layer. And I'll get quickly into what that means. So what that means is, once I have the model as Amazon S3, I can read the model from my container and use that model to predict images. Now, the application developer can write code, and the code is basically using those algorithms that the machine learning algorithm provides, and takes the code reads the model that was generated in Amazon S3 and commits that code into code commit, which is a managed GitHub repository on AWS. Now, the DevOps cycle kicks in if we have configured our DevOps well. The code, once code commit, it detects a commit code pipeline, it triggers the dev workflow, it sends the code to AWS code build. Code build builds the image and the binary, and in this case uploads the MXNet and the application image and stores the image onto Amazon ECR. Now, code build all and Amazon EC while this is happening, the infrastructure was provisioned using CloudFormation, and in this case what you see is we have provisioned a ECS cluster with multiple instances. We can use pod instances, we can use on-demand instances, and we also can use the auto-scaling. The ECS cluster or the API is load balanced using the application load balancer. It gives me flexibilities like dynamic port mapping and path-based routing and things like that. And finally, I have a DNS server routing based on Amazon Route 53, so I can redirect using a vanity URL down to the ALB and down to my service. When a mobile client or your user wants to predict an image, let's assume you point your phone and you click a picture. You want to know what this picture is, and let's say you're in front of the Golden Gate Bridge. The code makes a call to the front end, or the app makes a call to that vanity URL, which redirects it to the service, the MXNet service or the machine learning service that is running on ECS cluster. Now, this code compiles or predicts that this image looks like a suspension bridge with a probability of 11% in this case, and then it gives this answer back out. Now, to do that, first the code reads the model from Amazon S3 and then predicts it and goes back. The other part of this is all the data we are capturing from the image, we can put it back onto Amazon S3 and make that data available to the data scientists to do even more training, and our data set is getting richer and richer as we go. From a monitoring perspective, with Amazon ECS, you can launch custom metrics into CloudWatch and measure CPU, latency, and things like that, and show. And you can also do logs into your CloudWatch logs to see how your application is behaving, and hopefully get to a stage where you're looking for exceptions and not keeping the lights on. So we use Amazon S3 as a communication model between a communication device between the data scientist who stores the model into S3, the application developer who codes against it, and finally the DevOps lifecycle where the code really picks it up and also contributes the data back. So this is how we think of solving this problem, and we'll show you a demo of this next. So thank you. So let's go back and look at a quick demo of how this would work. So I would highly encourage you to go and read this blog, which is Deploy Deep Learning Models on ECS. This gives you a walkthrough of how to deploy, build the image, deploy it, and using the different artifacts and things like that. And eventually you will have a API which works out of the box. So let me log into my AWS account. So I've logged into my AWS account, and I'm going to go into my CloudFormation stack, and I don't have a stack launched in US West 2. So let me go, and from the blog, I can actually pick up where the master template is at, and the master template is at okay, let me find it through S3. So the link is on the blog. I just don't find it now. So let's go back, and let me go back to my S3 bucket where I've stored the master template. And this is where my master template is stored. Where I'm provisioning the infrastructure, where I'm building the code pipeline, the code build, and tying all the knots together. So I have 4 templates, and that's what CloudFormation also gives you, the modularity in maintaining your different aspect and separation of concerns. So on the master template, I tie the 3 things together, I built the VPC in a separate stack. I built the ECS artifacts like services, tasks, definitions in a separate stack, and I finally built my CI/CD artifacts in a different stack. So let's go and launch my master template and start to build my infrastructure. So I will put the S3 URL into the template URL into the S3 destination, and CloudFormation will pick it up. Let me give it a name. I'm going to call it MXNet West because that's what I'm trying to deploy. And finally, I'll give it IAM roles, the permission to create IAM roles so that it can create IAM roles and provision the infrastructure. So what you see here is the master template kicked in, and very soon you will see, like now, the different stacks being built. So we have a build stack and we have a VPC stack getting in, and soon you'll see an ECS stack also coming up. Building the machine learning module takes close to 10 minutes. So what I'm going to do in the meanwhile is switch a region and show you a pre-baked output and walk you through the different steps, and then we'll come back and check if this stack completed. So I have my master stack, and you can see the events that happen on the master stack, the resources I provisioned. In this case, there were 3 different stacks, and what are the status, and also the output. In this case, it's an API. So let's go and look at what did the VPC stack create. The VPC stack has created a default public route, my network subnets, and associates the route tables, and finally create a VPC on top of it to place my EC2 instances in. My ECS stack has created an ALB, the application load balancer, to load balance my service. It has created an auto-scaling role, CloudWatch log groups, container instances, EC2 role, and so on and so forth. And it has basically placed those instances. And finally, it has also created the service and the task definition, which is ACS way of placing Docker images into the cluster. You can watch different events, and I've received a success signal and all that. In case if there's a failure, you will also see this in this log. And finally, the output of this is I have a cluster, I have an application load balancer, a service, and a task def, and I'll go into details in each of them. And from a build pipeline perspective, what we've created is an app pipeline, a code pipeline, basically, a code build project, a couple of service roles, and there is S3 service bucket where I'm going to store the artifacts. So let's quickly jump into the code pipeline and see the dev workflow, how it came together. So here you see the application pipeline that I created through the CloudFormation, and this is a very simple pipeline, but you could do multiple trees and bifurcations of this. But what this does is picks up the code from code commit on a trigger and then pushes it to code build to build it. Let's look at the code. What did the code look like when I started working on it? So at the application layer, I have a Python script, and the script basically uses MXNet, and it loads the model. It's given an image, it predicts what it is, and it's a Flask application. It basically takes the image, and it basically tries to predict it and saying, hey, what is this image that I see? Your MXNet tries to predict it. I built this and packaged this together, as I mentioned earlier, using a Docker file and a Docker image, and I'm basically installing the dependencies. I'm installing the MXNet library, the Python packages, and the Flask packages, and finally I deploy the app and all the dependencies and expose it on port 5000. The other file which is really important to complete this pipeline is the build spec YAML, which we also talked about earlier. In this case, I have a build stage where I'm basically saying build this Docker image with this tag called ML test repo, because my ECR repository is that name, and I'll show you that. And finally, I get a short-lived token from ECR to push the image and tag the image and push the image. So you can call AWS APIs or other APIs right from the script, and anyone who has been through Jenkins understands the management pain that we go through, or we have gone through in our lives. Once the code we have seen the code that we want to build, the code commit picked up, triggered the pipeline, and code build was informed that, hey, this is the code that you need to build. So let me actually go one step back. So what you see here is a code build project provision. You can see the build details, what happened, and how this was configured, and the different phase details of how I provisioned, like what was the install step, what was the pre-build step, and so forth. And you can also see a short-lived log of 20 lines in the console, or view the entire log. The other, okay, let me go back to projects and go to the projects. You can also see the project details where I've set the timeout as 60 minutes, which is too high. You might want a lesser one. I've given an encryption key that we should use to work with. I've given it an image, which is Docker 1.12 on a Linux box, and I'm using 7 gig memory and 4 vCPUs. So you could, and I've given it a service role. You can actually play with these and this compute that you need and configure it accordingly. So my code was built, my code was pushed to Amazon ECR, as you can see from the log. My post build is success and true. Let's quickly jump into the ECS console and see what are the artifacts that got built with ECS. So I have a cluster, like I said, showed you from the CloudFormation template. It has one service and one container instance. The service, I told it to run one copy of the service, and it is running one copy right now. So I can go to the service, and at the service level, I've defined a target group. A target group gives you that flexibility to link it up to application load balancer and port map it down from 80 at the load balancer layer to 5000, and we'll see. You can also define a minimum healthy percentage, a maximum healthy percentage, and things like that. And you can also define task placement strategy if you want to target a specific instance.
Hi everyone, we apologize for the connectivity issues. It looks like we have lost our speaker. We will be back on momentarily, and we will let you know as soon as we're ready to continue.
Sorry guys, that was a small technical glitch during the demo is always good news. That means we are doing something right. So let's keep going. So in the container space, what you see is, as I was saying before, I've deployed the container, and I see that I've given it 4 CPUs, and I've given it 3 gigs of memory to run the prediction on, which probably it needs. I have AWS CloudWatch, which I'm linked into, and from the container, I can put the CloudWatch logs, and it automatically, and basically all my logs are getting written to CloudWatch logs without me writing a single line of code. Now, once that has happened, now this is my ECS cluster and my service is up. And so let's take a look at the repository where I stored the image in, which is ECR here. So the CloudFormation created the ML test repo. And you can also give it fine-grained permissions. In this case, it's pretty open, but I can give it fine-grained permissions where I can say allow or deny to a specific principal, which could be an AWS account number or a role or a service, and then give them very specific granular actions, permissions like push or pull, put image, or list images and things like that. With ECR, you also get the benefit of layer caching. I am not using layer caching in this demo for the definition. Let's take a look at the task definition quickly and talk about the different aspects of the task definition. And I'm going to click in there. You can model your task definition in a JSON basis, and you can actually push your different container definition, your volume mounts, and things like that. Or you can use the ECS API for doing that. So what we expect out of this whole life cycle and chain that we went through is an API that we can hit and work. Before we do that, let's go back to our original old region, which is Oregon, and see what is happening. So my stack is still building, and the reason it is still building is probably the build is still taking time, and let's check that quickly. And If we go there and click on the project, and if we go into the run, and you see that this is still building, and it's building the MXNet package for us. So once this completes, you will be able to hit the API and get the results out of it. So let's go back into US East 1 and show you the end result of this, which is the output is an image. I'm going to take the endpoint and open a REST client. In this case, I'm using Postman. And when Postman comes up, we'll be able to push the image. In this case, as you see, I'm trying to get an image with this URL and what I'm posting into it. Okay. So let's take this and change the ELB name to the ELB that I just deployed. Let's look at the image I'm trying to predict. So the image I'm trying to predict, and if I can take this off a little bit, is this image, which is the Golden Gate Bridge. Now, let's see what the prediction comes back as. And the prediction comes back as at 62% probability it's a suspension bridge, and then so on and so forth. So you saw how I took code, and if I have to make a change, I could commit the code quickly, run it through the dev pipeline quickly, and deploy a complex application or workload like machine learning on ECS and scale it and predict it with relatively nice performance from a machine learning prediction perspective. So that gives you a rough feeling of how the infrastructure is provisioned, how the code pipeline is provisioned, the dev workflow comes together, and finally it builds a communication model between the three different aspects of development as we move forward, which is data science, application development, DevOps, which is basically taking the development and ops and merging them together and using AWS artifacts and other artifacts, third-party artifacts, to get to a functioning API and keep it iterative and get the best out of your infrastructure. So with that, thank you.